Hi, welcome to your 8-3 flip video. 8-3 is called Solving Two-Step Equations, and it's a pretty straightforward lesson. It's really how to break down an equation like 5x minus 10 equals 50. And there's only a couple of steps, and they're really straightforward. So the first one is undo addition or subtraction. Second one is undo multiplication or division. And the third one I'm going to put in brackets because most of you don't do this, but is check your answer. So let's look at why this is true, and then we'll look at some examples. So I gave you an expression like 3 times 2 plus the quantity 5 divided by 5 minus 3, and I asked you to solve that. How would you do that? Well, you use PEMDAS, right? You do parentheses first, then exponents, then multiplication, then division, then addition, subtraction. So you'd work your way left to right through PEMDAS, and I'm going to kind of draw it as stairs. So it's like you're building up, you're building your way through PEMDAS. But if I gave you an equation like 3x plus 5 equals 26, how do you do that? Well, we know from the steps over on the left that we do addition, subtraction, multiplication, division, which, if you think about it, is PEMDAS backwards. So I'm going to draw PEMDAS going the arrow going the other way, but stairs going down to kind of represent we're deconstructing the math sentence given to us to find the value of the isolated variable, right? Because if you solve this, right, you'll get subtract 5 from both sides, 3x equals 21, and then we divide by 3 on both sides, x equals 7. So we deconstructed PEMDAS in order to find the value of the variable. So I'm going to make some notes on the side. Break it down. So you're breaking down the equation with PEMDAS backwards to get the value of the variable. We could also say we're deconstructing the original equation to get this new value for the variable. So I think about it like stairs building up. That's when you're using PEMDAS, and when you're solving, we're breaking down PEMDAS. So I like the stair analogy. So let's look at some problems. I'm going to throw up a couple here, and that's really all we're going to do in this video. So let's look at that first one, 9x plus 5 equals 50. So if we follow the steps, if we deconstruct PEMDAS, work through PEMDAS backwards, how do you get x by itself? How do you isolate x? How do you find the value of x? Well, we're going to subtract 5 from both sides. So we're left over with 9x equals 45. Those 5's canceled out, and 50 minus 5 is 45, so 9x equals 45. What does 9x mean? Well, 9x is 9 times x. How do you undo multiplication by 9? You divide both sides by 9. Those 9's cancel out by the x, so you have x equals 45 over 9. 45 divided by 9, x equals 5. Same thing for the yellow one, 10x minus 3 equals 27. Add 3 to both sides. Those 3's cancel. 10x equals 30, because 27 plus 3 is 30. How do you get x by itself? Divide both sides by 10. The 10's cancel out, and you're left x equals 30 divided by 10, which is 3. Here, I just want to add this, that the 10's cancel out. All right. For the blue one, we're now looking at x over 7 plus 11 equals 90. So, deconstruct, we're going to subtract 11 from both sides because that's how you undo addition by 11. These cancel out. You get x over 7 equals 79 because 90 minus 11 is 79. Now, x over 7 means x divided by 7. So how do you undo division by 7? We're going to multiply by 7. Now, I'm going to show you really quickly, just in this one example, why that cancels each other out. So if you multiply by 7, that's the same thing as multiplying by 7 over 1. Now, if you multiply two fractions and you have the same number in the numerator and the denominator, they cancel each other out. So this would just be multiplying fractions. 1 numerator times numerator, 1 times x is x, and 1 times 1, denominator times denominator, is 1. So 1x over 1 is the same thing as 1x, which is the same thing as x. So that's why the 7's cancel out. You don't need to know that. I just want you to know that it's not just like math magic where everything's just disappearing. There's a reason those 7's cancel out. There's a reason why you multiply, why multiplication undoes division. So if you multiply both sides by 7, you get x equals 79 times 7, which is 553. All right, for the purple one, x over 2 minus 5 equals 100. We're going to add 5 to both sides. x plus 2 equals 105 because the 5's cancel out on the left, and 100 plus 5 is 105. So x over 2 means x divided by 2. So how do you undo division by 2? We're going to multiply both sides by 2. Those 2's cancel. X equals 210 because 105 times 2 is 210. All right, the last example I've thrown in some negatives to really make sure that we understand this. So negative 3x plus negative 2 equals 15. So what is being done? You have negative 3x, and then we're adding negative 2. So how do you undo addition of negative 2? Well, we're going to just, why does it matter that it's a negative 2? How do you undo addition? You're going to subtract the same number. So we're going to subtract negative 2 from both sides. So on the left, that's easy. Those just cancel out. If you add two opposite numbers, they cancel out. If you add x and then you subtract x, they cancel each other out. So what do you have left over on the left-hand side? You have negative 3x equals, now for this I'm going to write out a math sentence, an expression on the right-hand side to help us figure out what 15 minus negative 2 is. So 15 minus negative 2. So you have, remember, in topic 4, we added and subtracted rational numbers. Minus the negative is the same thing as adding the positive. So it's kind of like those two negatives line up to make one big positive. So you have negative 3x equals 15 plus positive 2. Well, 15 plus positive 2 is 17. All right? So you have negative 3x equals 17. So what's happening with negative 3x? Well, that's negative 3 times x. So I'm going to throw some parentheses around that negative 3. It's negative 3 times x. So how do you undo multiplication of negative 3? You're going to divide both sides by negative 3. So the negative 3's on the left cancel each other out, and you get x equals 17 over 3, negative 17 over 3. So you can leave it like that. That is as simplified as it gets, or we could change it into a mixed number. How many times does 3 go into 17? Well, it goes into 5 times because 5 times 3 is 15. If you pull 15 out of 17, you're left over with 2. So x equals negative 5 and 2/3. So both of those would be fine, acceptable answers. All right? Don't get caught up just because there's negatives floating around. Just follow the steps. You undo addition with subtraction. You undo subtraction with addition. You undo multiplication with division. You undo division with multiplication. Don't get tripped up. All right. 8.4 will be problem solving with the distributive property. So we'll be taking all this information and taking it one step further with the distributive property. Let me know if you have any questions.